everyone. This time we will learn how to convert one complex number to another. We have already learned that there are different forms of complex numbers, namely the rectangular, we have the polar, the trigonometric, and the exponential. So the question we face now is how do we convert one complex number to the other? And we can do that by using what we call the Argand's diagram. It was developed by a French mathematician, Jean-Robert Argand. Argand's diagram is much like our Cartesian coordinate system. So it is a coordinate system showing the real and imaginary axes for the presentation of a complex number. So unlike the Cartesian coordinate system that only represents the real number, Argand's diagram can be used to represent the real and complex real axis and imaginary axis of complex number. So just like the Cartesian coordinate system, this is how the Argand's diagram basically look like. So here we can draw our complex number, and let's say this complex number is z equals 3 plus j4. That means the x component is 3 and the y component would be equal to 4. So this is the representation of this complex number 3 plus j4 in the Argand diagram. So the coordinate here is 3, 4, where x represents the real part, which is 3, and 4 represents the imaginary part, which is 4. As you can see, we have a line here, okay, which forms an angle with the x-axis. And so you can already see that if we get the resultant of 3 plus 4, if we get the hypotenuse of 3 plus 4, that will be now our r in terms of, so another, let me rewrite it. So if this is 3, 4, now this hypotenuse is what we call our r, and this is now our theta. So which means that if we obtain our theta and if we obtain the hypotenuse of this triangle, we can already obtain our r and theta for our polar form of complex number. So as you can see, we can simply convert our rectangular form into polar form by taking the hypotenuse and the angle theta. So now let's try to convert 3 plus j4 in terms of its polar equivalent. Okay, so the first thing we do is we get our r, and r is simply equal to the square root of x plus y, and our x is equal to 3 and our y is equal to 4. Okay, so x squared plus y squared, 3 squared plus 4 squared, using Pythagorean theorem, we have our r, which is equal to, r is equal to square root of 3 squared plus 4 squared, which is 5. This is 9 plus 16, 25. Square root of 25 is 5. So this is our r. And r theta, we obtain r theta, that is, if you remember, the trigonometric function for opposite side and the adjacent is tangent. So tangent theta is equal to opposite over adjacent. The opposite is 4 and the adjacent is 3. So which means theta is equal to arctangent of 4/3, and theta, arctangent of 4/3, is equal to 53.13 degrees. So now we have we have converted already our imaginary number, our complex number 3 plus J4 into its polar equivalent, which is 5 bar angle 53.13 degrees. Okay, so if you have, once again, if you have a complex number in rectangular form, you simply take the real part and place it in the x-axis, and the imaginary part and place it in the y-axis, and then you draw a resultant line, and this now represents our complex number. And then you can convert that into its polar form by simply taking the magnitude, the magnitude or the hypotenuse, and that represents the magnitude of our polar complex number in polar form, and then taking the angle using the trigonometric function tangent, and that represents the argument or the displacement of our of the complex number in polar form. Now let's take one example, and that is convert 6 minus j3, which is in rectangular form, and convert it to polar form, exponential form, and trigonometric form. So again, we use the Argand's diagram to represent the complex number in rectangular form. So if this is the Argand's diagram, 6 minus j3, 6, the x-axis represents the real part, which is 6, positive 6, and the y-axis to represent the imaginary part. But as you can see, it is negative. So we go down 3 units. Okay, we go down 3 units. So 1, 2, 3. Alright, so if this is 6 units, 1, 2, 3, 4, 5, 6. So this is the point, which is positive 6 and then negative 3 in y. So this is this line represents the complex number 6 minus j3. Okay, we can form here the angle theta in order to obtain the polar equivalent. Okay, so this is 3 units here, the side opposite, and 6 units for the adjacent side. Okay, so first what we will do is we use the Pythagorean theorem in order to get our resultant r. So this is the resultant, the magnitude r. So r is equal to the square root of 6 squared plus 3 squared. Alright, so 6 squared plus 3 squared, and r is equal to 6 point. By the way, this is negative 3, right? So, but then when you square negative 3, it is still equal to positive 9. So this is equal to 6.708 using your calculators, and then 6.708 units. And then our theta, that is tangent theta, is equal to opposite, which is negative 3 over adjacent, which is positive 6. And so theta is equal to arctangent of negative 3 over 6. And arctangent of negative 3 over 6 is equal to negative 26.57 degrees. So this angle is negative 26.57 degrees. Okay, so therefore our polar equivalent of 6 minus j3 now is equal to, z is equal to 6.708 bar angle negative 26.57 degrees. So this is the polar equivalent of 6 minus j3. Now this is very easy to convert. Once you have obtained your polar equivalent, this is now very easy to convert to trigonometric form because you simply copy the value 6.708 and you write CJS negative 26.57 degrees. As you have already said, CJS represents cosine minus j sine theta of 26.57 degrees. Now, the last thing we need to do is to convert this into exponential form. So for the exponential form, you simply copy the r, which is 6.708, and then we simply convert negative 26.57 degrees to radian. So how do we convert degrees into radian? We simply multiply it by pi over 180 degrees, where we cancel our degrees, and the resulting here is pi radian. So negative 26.57 times pi over 180, and that results to negative 0.464. Using your calculator, negative 26.57 times pi divided by 180 is negative 0.464. So therefore, the exponential form now is you copy 6.708, which is the magnitude e raised to power of negative j 0.464. So the complex number 6 minus j3 is 6.708 bar angle negative 26.57 degrees in polar form, 6.708 CJS negative 26.57 degrees in trigonometric form, and 6.708 times e to the power of negative j 0.464 in exponential form. The next example is to convert 5e j 0.725 to rectangular form and trigonometric form. Okay, so same process, however we reverse it because right now we are to convert a complex number in exponential form to rectangular form and trigonometric form. In our previous example, we have converted from rectangular form to trigonometric form and then to exponential form. This time we do the reverse. So we know that 0.725 is in radian, so we have to convert it into degrees first. So that is 0.725 in radian, and converting it to degrees, we have pi radian in the denominator and then 180 degrees in the numerator. So cancel these units, and we have, using your calculator, we have 41.54 degrees. Alright, 41.54 degrees. Now we have already obtained the polar form of the complex number 5e j 0.725 because we simply copy the magnitude 5, and then we use for our argument or displacement the angle, the degree form of the argument in exponential form. So that is 41.54 degrees. So this is now the complex number in trigonometric form. Now how do we convert trigonometric form of complex number into its rectangular form equivalent? We still use the Argand's diagram. So this time we know that if this is the diagram, 5 represents the magnitude, which is the hypotenuse, or the magnitude of the hypotenuse of the two sides representing our real and imaginary axis now for rectangular form. So we have 5 here, and then the angle is 41.54 degrees. So our task is simply to obtain the x-axis and the y-axis, and these axes represent now our our rectangular form. So x plus jy. So how do we get x and y? We use the trigonometric function. We use the trigonometric function sine and cosine. Alright, so if this is 5, then if we are to get x, you remember that sine theta is equal to SOHCAHTOA sine is equal to sine theta is equal to angle opposite over hypotenuse. SOHCAHTOA cosine adjacent, side adjacent, and the hypotenuse. And TOA tangent is side opposite over hypotenuse. So sine theta is opposite, which is y, over hypotenuse, which is r or 5. And another one, cosine theta is equal to SOHCA adjacent, side adjacent, which is x, over hypotenuse, which is r or y. This is r, right? So theta is equal to 5 transpose 5 to the other side. So this is the theta is equal to 41.54. So y is equal to transpose 5 here. So this becomes 5 sine theta, but theta is equal to 41.54, right? So y is equal to, solving for the y, we have 3.316. Using your calculator, 5 sine 41.54 is 3.316. And x now is equal to 5 cosine of the angle again is 41.54 degrees. So x is equal to, using your calculators, we get x equal to 3.742. 3.742, and so therefore our equivalent complex number in rectangular form is x plus jy, right? So 3.742 plus j 3.316. So this is the equivalent complex number in rectangular form. Okay, so by the way, the trigonometric form of this complex number is simply from the polar form. We have z equals 5 CJS 41.54 degrees. So this is the equivalent complex number in what we call the trigonometric form. This time I will teach you the shortcut using your calculators. I have here a calculator which is Casio 570 MS. There are more recent model of calculators, but basically the function is the same. So the first thing that you need to do is to set your calculator in complex degree. So you press the mode, and PLX represents complex number. So I will press 2. Then so as you can see, it's now in complex mode. And then I will type in 5 angle 41.54. That is, type 5 and then shift. You see this angle, so 5 angle 41.54. Alright, so then you see this. Okay, this is a complex number in rectangular form, so we need to convert this to complex number in rectangular form. So you simply press shift and then this one. Alright, so that means we are converting polar form into rectangular form. So you press equal. So we have 3.74 for the real part, 3.74 as you can see. And then for the imaginary part, you need to press again the, as you can see here, real to imaginary. So the imaginary part now is you press shift and then imaginary part. So 3.31.50, 3.3157. And then same thing if you need to convert real part complex number in rectangular to polar, same thing. Let's say we will convert this one to polar. Of course it will not be exact because of conversion, I mean the rounding off. So 3.742 then plus, okay, plus 3.316, and then we need to find the I, which is the imaginary number, and as you can see the I is here. So this one, right, the I. So then shift to polar, and then equals, so 4.9899 or 5, and then again, once again the imaginary part, shift imaginary part equals, shift equals for the imaginary part, which is 41.54. So you have already learned how to convert complex number from one form to another using the Argand's diagram, manual form, and then using your calculators as well. So I hope you have learned something, and God bless.